All right, everyone, we are back, and now we're going to do our fan control lab with our Vernier Photogate, calculating the RPM, but now in a controlled manner. So, power supply, 12 volts, approximately. That feeds directly into our old friend, our power supply on our motor controller. A and B go directly into our fan. We have our direction, and the direction, because we're not flipping it, it's just going to be shared with our ground. Our pulse width modulation goes to our old friend, our analog output A0, 0 to 5, to modulate that 12 volt excitation. We have essentially our ground that's here, and that's also shared with the ground there. So we're going to select a target RPM. We're going to have a control interval that you can kind of change, and I would try to make it, pretty robust as best as possible. We're going to change a proportional controller, so that KP value will change. And this is a 5-minute run. You could probably, to get some good statistics, maybe at least 2 minutes. So maybe just 2 minutes. But you can change that depending on the experiment, depending on what you want to see. Name your file, so KP RPM, I'm going to say 2500, because that's going to be our target, and then we'll have our time. So I'm going to go ahead and press play, and then we can see our controller. It's ticking, trying to keep that, and we're getting a live readout as well of our RPM and that voltage input. So we're trying to hit that 2500. And you can see it keeps ticking, trying to keep. So you're going to do that. You're going to measure, and the output is going to be essentially our RPM versus time. And then you're going to see the performance as we change some of those proportional controls and other values. So we'll see you then. Thanks. In the next video. Bye. All right, everyone, we've ran a couple of our tests, and now we're going to start to analyze and look at the data. So I have one setting here where we did our KP value of 0.001, and our set point was a 3,500 RPM, and then another KP value proportional control of 10. So what is it? 1, 2, 3, 4 orders of magnitude higher. And you can see here at this proportional control value, we can't even hit our kind of baseline measurement here. So we don't have enough proportional control to actually drive and hit our kind of set point. And you can kind of see these kind of clear fluctuations where we're just not even hitting it. The error is constant. Here you can see improved control, and we're actually able to hit that at that 10 kp value. Now there's some, as you increase that kp, you get that faster, kind of response, but you can get that overshoot, undershoot value as well. We did a set point that was slightly lower, 2,500 here, and I want to bring your attention to the first 3 files. So one cool thing you can see here is this is, again, the 0.001. Again, we can't hit that value. But what's really cool is if we look at file 2 and file 3, so 0.01 and then 1. So you see blue is the 0.01, and you can see we're kind of hitting our mark, but you see kind of these lulls, and the response isn't as, we're not getting that kind of, clear response to kind of keep us driven at 2,500, but as we increase here, so you can hit some sweet spots of KP values where you can see some of this clear behavior that we've talked about in class before. So hopefully you can kind of tune and see some of this behavior. So see you next time. Thanks. Bye.